Ciao friends and welcome to a new video from SQL BI. In this video, I want to talk about variables in DAX. As soon as you start writing DAX code, you quickly realize that variables are an important pillar of writing DAX code because they improve not only performance but also, and most importantly, the readability of your code. So I'm going to introduce variables in a simple way, then we will digress a bit, understanding why variables are useful and what are some best practices when using variables. Then we'll discover when variables are evaluated by looking at some of the mistakes that newbies often do when using variables and DAX code. And finally, we'll answer an important question. When are variables being evaluated in your DAX code? If you define multiple variables, are they always evaluated all the time or not? What are the scenarios when a variable is evaluated and when not? And we do that the usual way. We start writing some DAX code together, and in the process of authoring code, we learn some details about this beautiful language. So, with no further ado, let's get started with the demo. In the example I have on the screen, I'm just computing the sales amount and slicing it by year. There's nothing fancy here, it's just a simple report. But I want to project on the same matrix also the average sales per customer. There are multiple ways you can obtain the same result. We are going to just compute the sales amount and divide it by the number of customers. If we were to write the code with no variables, we would write something like this. We create a new measure, we call it sales per customer, and we need to perform a division, so we divide the sales amount, and we can use the measure sales amount, divided by the number of customers, which can be computed, for example, using a distinct count of sales customer key. This code just works. We just need to format it as a decimal number and place it in the matrix. So that shows the number sales per customer. As it is, it works just fine. However, if we want to make it more readable, we can use variables to provide names to expressions. A variable is introduced in DAX by the var keyword. You write var, then a name like sales amount, and then you store an expression like the sales amount. Whenever you introduce a variable, you always need to add the return statement. Return indicates the result of the expression. So we just use return, and in the return part, instead of writing the expression sales amount, we can just use the variable. I'm not changing the code in any way, I'm just changing the way the code reads. It is way better and way easier to understand. For the sales amount, that doesn't seem so relevant, but for the distinct count of sales customer key, whenever you look at the code, you need to remember what it is being computed, which is just the number of customers. So instead of defining just a variable for the sales amount, I can define another variable, number of customers, that computes the distinct count of sales customer key. So you see that in a single block I can define multiple variables, as many as I want, and there will be only one return statement. And once I provide a name to number of customers, I can just use it here, and I divide the sales amount by the number of customers. In this simple example, there is not a big difference, both in terms of readability, and there's no difference at all in terms of performance. But you see that just by providing a name to an expression, when you read the divide statement, you don't have to remember how number of customers is being computed. You know that it's a number of customers and the code is more readable. This code works just fine. However, at SQL BI, we are used to use a different and more powerful pattern. Instead of returning an expression, we always use a final variable, result, where we store the final result of the calculation, which is divide sales amount by number of customers. And then the last statement is always return result. So again, what's the rationale behind this choice? Well, depending on how complex your DAX code, at some point you will need to debug it. You will need to understand why a number might be right or wrong. And if that is the case, a very useful technique is that of inspecting the result of partial calculations in order to see where the problem appears. So if at some point I need to debug this measure, I might want to see what is being computed in sales amount, what is being computed in the number of customers. And to do that, I can simply replace the last line. Instead of returning result, for example, I return number of customers. By doing that, you see that the matrix now shows the number of customers. I can look at the number, make a decision, check if anything is wrong, and when I'm fine and I'm happy, I know that in order to restore the original measure, all I need to do is just use return result. I don't need to remember what was the last expression that was used inside my code. Something that is not evident at the very beginning is that variables are typically defined at the beginning of your expression. So in this example, we use sales amount and number of customers as the first two lines of the entire DAX expression. However, for more complex code, you can introduce variables at any point in your calculation. And in order to show you this, I'm going to use a different example. Instead of computing the sales per customer, we pretend that we make a 15% discount for every customer that bought more than the average number of customers. If we were to write that without variable, that would be quite complicated. We can create a new measure. Let's call it discounted sales. Discounted sales. And we need to iterate customer by customer, compute the sales amount, and compare it with the average sales of all the customers. This is not trivial because you start with some x, and then we iterate over the customer. For each customer, we check if the sales amount, and we can use a measure, is greater than, and here I need to compute the average sales of all the customers. The reason why this is not trivial is because I'm iterating customer by customer. So if I invoke here the sales amount, I compute here the average sales amount, I will be somewhat forced to use the row context created by some x. So computing inside an iteration, calling another measure that computes something is always troublesome because the row context is being transformed into a filter context. So it would be better to split the calculation into steps. And variables are just perfect. We can use a variable, let's call it average sales, where I just use average x over customer of sales amount. The expression by itself is rather simple, and by defining it at the beginning, I don't have to worry about iteration happening before. And in the return part, I can check if sales amount is greater than the average sales. If that is the case, this is a good customer and I want to apply a discount. So I compute again the sales amount times 0.85, so we have a 15% discount. If otherwise it's a regular customer, then we just compute the sales amount. And then we close it. Again, with one variable, the code just works. We format it as a decimal number, place it on the matrix, and this shows some number that of course is smaller than the total sales amount because there is this 15% discount. However, when I look at the code, you see that I'm using sales amount once here, twice here, 3 times there. Does it happen that DAX evaluates a sales amount 3 times? Maybe. Maybe yes, maybe no. We don't actually know. However, using a variable will ensure that the evaluation happens only once. So it would be great to define a variable, and we can do that even inside the iteration. We can start a var block here, create a variable that we call sales or customer sales, where we store the evaluation of sales amount. And in the return part, instead of computing sales amount 3 times, we use the variable. So we have customer sales here, here, and here. This small change, let me also format the code in a better way. This small change makes sure that evaluation of customer sales happens only once. We can go further than that because 0.85 is a discount percentage, so we can add another variable only for readability purposes. So we create a variable, okay, another variable discount, which is 0.85. Is this going to change performance in any way? Not at all, because I'm just providing a name for an expression, but this is going to help you a lot while reading the code later. And then, because I always do that, instead of returning the expression, we return result. So we define a variable result when we store our calculation, and finally we use return result. Again, nothing is going to change in the code. That's the same number computed in a more readable way. And because we apply the pattern of returning a result in the inner box, we can also do the same here. We define a variable result, and we return again result. This is useful for a couple of reasons. You see that I can define a variable named result, and inside that I can define another variable in a nested block whose name is still result. There's no ambiguity here. The outer result is being hidden by the inner result. So when I reference this result, I'm referencing this expression. And when I'm referencing this result, I'm referencing this expression. The same name in nested blocks means that the innermost one is being used. However, unless you use the same name, you can use variables defined in the outer blocks in the inner box. And you can see, for example, here, I'm defining average sales outside, and then I'm using average sales inside. So you define a variable, and in the return part, you can use all the outer variables. Plus, you can nest variable blocks, and they will be working nicely together. Using variables greatly helps in making the code more readable. However, many newbies make the mistakes of confusing variables with measures and not understanding clearly that variables are actually constant values. Despite their name, variables are constant. Let me show you this with another example. If I create another calculation, I don't have it, so I need to write it from scratch. Let's pretend that I want to compute the growth between the previous year and the current year of sales amount. I can write this measure easily. Growth. I need a variable, sales amount, that computes the sales amount. And then I need the sales in the previous year. I can do that. I can define another variable, sales of previous year. I use calculate, and here I should write the sales amount, but I already have a variable, so I can use the variable and then use same period last year to move the filter context back 1 year. So I use date, same period last year of date. And then I define a result, variable result, which is the sales amount minus the sales in the previous year. Return result. There seems to be nothing wrong with this expression. However, this is going to return 0 all the times. Indeed, if I take the growth and place it in my matrix, you see that the result is 0 everywhere. Why did this happen? Well, the reason is I used the variable here. And you need to remember, variables are constant. Variables are evaluated once and they will never change their value once they are computed for the first and ever time. So sales amount is being computed here and then it is being referenced there, but it's not going to be recomputed. The value of sales amount is computed here, and despite calculate moving the filter context back 1 year, sales amount is not going to be recomputed. Variables are constant. So you might wonder why variables are not named constant and they are named variables. Well, the answer is simple. Nobody knows. But variables are constant. So instead of using sales amount here, you should use the measure reference sales amount. By doing that, you obtain the goal that now the calculation works and the growth actually computes the growth between the current year and the previous year. So obtaining the current number means also understanding when variables are evaluated. This is also relevant in the example we have done earlier about the discounted sales. Because you might wonder what happens if I define the variables in the outer block or in the inner block. Well, variables are evaluated in the filter context or in general in the evaluation context where they are defined. So let's pretend that let me get rid of growth. Let's change a bit discounted sales. If I look at discounted sales again and I say, well, I'm defining two variables here, and I could actually define the variables outside of the block. For example, the customer sales variable could be defined here. Is it going to produce the same result or a different result? Well, in this specific case, this is going to produce a different result. And you can easily tell by looking at discounted sales that now shows 58, well, let's say 1,000 millions billions. So it's 58 billions. That is so much larger than the sales amount. Why did this happen? Well, because in discounted sales, computing customer sales outside of the iteration provides a completely different result. This is now computing customer sales for all the customers and then multiply it by 0.85, always because the sales of all the customers is actually greater than the average sales all the time. So the place where you define a variable means a lot, and you always need to carefully choose where to define a variable so that it is computed in the evaluation context where you actually want it to be computed. Placing it in the right place computes the correct number. What about this average sales? Can I move this average sales inside the iteration? Well, in this case, the answer is yes. It will still work. If I hit enter and I look at the code, it still computes the correct number. However, from a human standpoint, this is much harder to understand, because you have an iteration happening of a customer, and inside this iteration you're performing another iteration again of a customer. So this sales amount is actually referencing the correct row context, the one created by average X. But as humans, this is harder to understand, so there's no point in doing that. You define the variable where it makes sense to define it, outside, and then you just use it inside. The code is much easier and much more readable. However, I promised you at the beginning, there is another important point that I want to discuss. That is, are variables always evaluated? Are there any chances that you define a variable and the evaluation doesn't happen? The answer is quite simple. A variable is evaluated if it is referenced in the code. Doesn't mean that it needs to be used. It is enough that you reference the variable. So if you define 5 variables, you can make sure that if you use those variables in your code, they will be evaluated. In some very rare scenarios, this might lead to slower code because you evaluate the same code multiple times. But in the vast majority of the scenarios, evaluating variables multiple times or always evaluating variables is not a problem at all, and it actually improves performance, despite this not being very intuitive. But we talk about all these details in the Optimizing DAX training. That would be overkill for this simple session. So when are variables evaluated? You could discover if a variable is evaluated or not by looking at the query plan. We can write a piece of DAX code, investigate the details of the query plan in order to check if there is a reference to some code that actually evaluates that variable. However, for this simple video, I will go for a much simpler version of test. I simply define a variable that generates an error. So if the variable is evaluated, then the error will appear. If the variable is not being evaluated, then no errors will appear. Let me show you the code. It's rather simple. I define a variable R that contains an error. I'm your favorite and personal error. Then I compute the number of customers as the distinct count of sales customer key, and I return as a result. If the number of customers is less than 0, then I return error. Otherwise, I return blank. Now, if you look at this code, because the number of customers is a distinct count, there are no possible ways that this returns a negative number. So this if statement is always false. Therefore, error will never be returned, and there's no reason to evaluate it. However, the engine needs to evaluate it just because it is defined in a variable. So if I place this code and I drop it inside my matrix, you see that I obtain an error. And if I look at the details, it says, oh, calculation error, I'm your favorite and personal error, because the error variable has been evaluated. In order to avoid the evaluation of a measure, you simply just need not to reference. If we use blank here, now the scenario is different. I define the variable, but nowhere else in my code I use that variable. Therefore, the DAX engine removes the variable because it knows that there are no needs to evaluate the variable. And if I hit enter now you see that my test1 measure always returns a blank as expected, despite a variable being defined containing an error. There is another scenario that is quite rare but might happen where a variable will not be evaluated. And that is if the DAX engine can understand from a static analysis of the code that the variable is actually useless. So what happens if I replace this distinct count of sales customer key with the count rows of all customer? And then I restore here, rather than blank, my error variable. If I hit enter now, you see that test1 returns a blank. I am referencing the variable, however, the engine computes the value correctly, meaning that this piece of code is not going to be executed. How come that this is even possible? Well, as part of the optimization process of the DAX engine, during the processing of your model, DAX stores the number of rows of all the tables, because it happens several times that you might count all the values of a column, all the values of a table, or all the values of a specific expression. For columns and tables, the engine knows in advance that there are exactly around 5,000 customers in my model. Actually, we can take a look at the number just to make sure. If we look at customer, where is it? There are actually 5,585 customers at all. So, because of this, the engine knows that count rows of all customer, that is actually 5585, and it knows that without having to look at anything. It doesn't need to execute DAX code. So it has 5585 here, so it replaces number of customers less than 0 with 5585. This condition is always false, and therefore the engine knows that error will never be returned, and the optimizer gets rid of most of the code and always returns a blank, because this measure will never return any value. This optimization works in import mode. If you were to do the same in direct query, for example, well, direct query is different, because in direct query the engine does not know about the data. The data is stored somewhere on a SQL server, therefore every time the engine needs to execute code in order to obtain the number. And in that case, a static analysis of the code would not produce an expression that doesn't use the variable. Therefore, the variable would be used. Or if you use any expression that is somewhat dependent on the filter context. If you just do a count rows of customer without all, then this piece of code depends on the filter context. The evaluation in every row would be different. And if that is the case, you obtain the error again. Well, not in the case, because I'm not slicing by customer, so I need to get rid of the year. Okay, and instead I can slice, for example, by any attribute of the customer, like the continent. Now, test1, because I'm slicing by continent, the number of customers depends on the continent, which is part of the filter context, and I obtain again my error. I'm your favorite and personal error. So this last part was about when is a variable is evaluated. A variable is always evaluated once if you reference it in your code. So, as you have seen, variables are quite interesting objects in the DAX world. They are extremely useful. Whenever you need to write DAX code, use as many variables as you can. I oftentimes provide a rule to my students, that is, whenever you are in doubt between using a variable or not, just use it. Because the number of scenarios where your code will be slower or worse is really tiny. Mostly variables improve performance of your code, they improve readability and make your life easier, because when you will look at your code later, you will enjoy it a lot more because those names for variables greatly help. Variables are evaluated only once in the filter context where they are defined. In general, in the evaluation context where they are defined. Choosing the right place where to store a variable is important. And variables, once defined, they are always evaluated. Take that for granted. There are scenarios where variables are not being evaluated, but that only happens in import mode, where a static analysis of the code provides the DAX engine a clear picture about the fact that the variable will never be used. But if you reference the variable anywhere in your code, you can make sure that once it will be evaluated. And then never again. Once a variable is evaluated, it never changes its value. Therefore, variables are constant, but we still love them and name them as variables. Enjoy DAX!